Good morning, everyone. It's a pleasure to be here. So how many of you have a benthic monitoring program? Oh, okay, just a few. What about a flow monitoring program? Okay, great. So this was definitely a team effort. Many folks contributed from Herrera on this project, so I just want to recognize those folks here. And I also want to do a shout out to Mindy Phone, who was the instigator of this whole project. I joined Public Works back in last August, and so sort of came in on the tail end of this work. But I just wanted to recognize her for getting the ball rolling on this project. So Kitsap, well, the Clean Water Kitsap program is what used to be called our Surface and Stormwater Monitoring Program. I'm not sure if you're familiar. We rebranded it a few years ago, and the reason I just want to point this out is this is a partnership program between Public Works, the Public Health District, the Washington State University Extension, the Conservation District, and also the Public Utility District. And we can obviously do a lot more together in this partnership than we can individually. However, our benthic monitoring program has been around for a while. As Ann mentioned, we have about 20 years worth of data. So what this shows is that since 2010, we have samples that are collected in about 31 streams throughout the county. And we got about 44 samples collected every couple of years, some every 1 to 3 years. It varies, but the bottom line is we've consistently been monitoring these sites since 2010. So we have that data set. When we go back to look at more older data, it's a little bit more sporadic, as shown here. So we have some data collected between 98 and 2006, 3 streams, multiple sites, and then the stream team collected some. Anyway, so we took all this data and then we worked with Herrera to give us a sense of, okay, what's going on with the data that's been collected? What kinds of trends and what kinds of things are we learning from these data that's been collected? This is the most current map that I don't expect you to read. It's kind of an eye chart, but what it shows you is essentially a distribution throughout Kitsap County of where our sites are located. I'd be more than happy to send you this if you'd like to take a look. But what the tables show are the years that those sites were sampled and then what the scores were. Our flow monitoring program, like any, is an important tool to assess Kitsap County's use of low-impact development techniques for new and retrofit projects. But it's also where we work with the Public Utility District, who sets up a network of stream gauges to better understand the hydraulic changes in the county. KPUD maintains these sites, and they provide stream flow and rainfall data to us, which also informs our benthic program. All right, so I have a short role this morning. That's it. I just want to introduce, and I'm going to turn it over to Joy. Thank you.
You did a great job on that short role. So starting with our project goals, well, first I'm going to talk about 2 pretty disparate things: the macroinvertebrate analysis and then the flow data analysis. During this first phase of the project, there was little connection between the 2, but in future phases, depending upon what we find, we may reconnect them up again. So in the macroinvertebrate analysis, probably the most important part of this analysis was the first goal that we had, which was evaluating whether there was an individual metric within all of those used in the BIBI that might perform better as an early indicator for trend detection. And then a second goal was looking at long-term trends and then short-term trends in the data. And in the flow data, what I'm saying here is that we wanted to evaluate how much of the observed variation in flow is associated with precipitation. But actually what we were trying to evaluate was the opposite of that. We were trying to correct for precipitation and see if there were still trends left in the data. So you'll hear more about that in a minute. I am getting over a cold, so please excuse me. So question 1, is there a metric that's better for early trend detection? And this really was, I think, the thing that Mindy was most excited about. You guys know we have these BIBI indices. They are roll-up of 10 different metrics. And but it is just like any other index. It's like the S&P 500 or the Dow Jones Industrial Average, and I'm not the best person to quote these things, but we do all hear things like they say, well, the Dow Jones is declining, led by a decline in, you know, IT technology or something like that. So they know that the index is going down, but they also are saying something about what's pulling it down or what's leading the way, and that was kind of what Mindy wanted us to find out. Were there some of these metrics that are better early trend detectors? So I'll go through this for the same kind of series of steps for all of these different questions that I'm answering. So the first in this was our data culling set. Data culling, we wanted to select sites that had at least 5 or more consecutive years of data. So of the 123 sites that Kitsap County has, there were 26 sites that met this criteria. So once we had those sites sorted, we applied, excuse me, both parametric and non-parametric correlation coefficient tests to the data, and then evaluated the results. So here are the results from the Pearson's R correlation. In the next slide, I'll give a little bit of summary of the comparison between this and the Kendall's tau, but they were quite similar for what we were looking at. So I'm not going to go into too much detail on them. Nonetheless, these are our results. So of the 26 sites, there were 16 that had a trend for at least one of the indicators or for BIBI. And what we're showing here is the darker green have a higher, were significant at 0.05 alpha levels, and the lighter green at 0.1. So we're trying to show different significance levels as well in this. And so this is my comparison to the Kendall tau, and those that are orange are places where the Kendall's tau showed some statistical significance, but Pearson's didn't. As you'll see, for most of those, they are like single places where just one metric was significant rather than multiple metrics. This is one of the things we were looking at. And then I put in red those excuse me, cells where the Kendall's tau showed a lesser significance, so slightly weaker significance. So I'm just trying to make the point that there really was pretty good a match between the two statistical tests we were looking at. So were trends detected? Yes. So at 7 to 8 out of the 16 sites, we saw trends for 2 or more metrics. And at 4 to 5 of those sites, there were 3 or more metrics. And that was one of the things we were looking at. It's not just one metric showed a trend, but if we saw 2 or 3 or 4, then we start to feel a little more confidence that there is, in fact, a trend showing up. Was the trend direction consistent? So we saw a trend, but did all of the metrics go up, or did some go up and some go down? In this particular case, or in this first question, by and large, with one exception, the trends all went in the same direction. Was there consistency between the tests? I've already talked about that. Yes, there was pretty good match between the results. So which metrics showed the most promise for early trend detection? So the clinger richness and percent predator were definitely seemed to be the strongest one, with 6 to 8 or 6 to 7 of the sites, of the stream sites showing that had significant trends, had them for these 2 metrics. The mayflies also were pretty good, the ephemeropterans at 4 to 5. The other 3, taxa richness, percent tolerant, and the BIBI, not so much. And I think this is to make this point that if we use the BIBI index to look at these trends, at more than 3/4 of the sites, we would not have observed a trend looking at the BIBI index. So we're actually looking very much at site by site data, but I think it does kind of emphasize that these trends may in fact be occurring. So these are probably the best of the sites in terms of that. So at the first 2 sites, we had 4 metrics or 3 metrics that all went in the same direction and all showed a decreasing trend. So we're saying those are either likely deteriorating or probably deteriorating. These are just my words. And then the same, only in the reverse direction for the next two. So we saw two other sites that had 4 or 3 metrics that showed an improving trend. And then the last site I only included, it was just 1 or 2 metrics that showed a decreasing trend, but it's Chico Creek, which is the same as the first one that I talked about. So again, maybe more indication that a trend is occurring in that stream. So the second part of the macroinvertebrate analysis was looking at long-term trends in the data. In this case, the data culling considered looking at those sites for which there was data for both pre-2008 and post-2008. So we just separated the sites. By doing that, there were 11 of these 123 sites that met that criteria. We just used, because we were just looking at the 2 different time periods, we used a Mann-Whitney 2-sided U-test. If we saw significant differences, then we used whisker box plots to decide what the central tendency was of that data. And okay, those of you who know me know I like my flying monkeys. You can't look at data like this without having some flying monkeys. So here it is. So these are, of the 11 sites, counting them quickly here, okay, there were 7 that we saw a trend in at least one of the metrics. But as you can see, those trends were mostly single. So 4 of the 7 sites, there was just 1 metric that showed a trend. So, not a lot of confidence. And then this, of those 3 sites that had 2 metrics, they went in opposite directions. So that really wasn't a happy data set, therefore the monkeys. And then short-term trends. So in this case, we just looked at the data from 2010 through 2015. There were 56 sites that were monitored during that period, but we also wanted to look at those that had at least 5 consecutive years of data. And so again, we got down to 11 sites. Once more, we applied Pearson's R, so parametric and non-parametric correlation tests to the data, and then looked at trends. So here are the results from the short-term analysis. We're seeing some, what I neglected to say the last time is that those metrics that we saw trends for were totally different than the metrics where we showed a lot of trends in the first step of the analysis. But here they come up again. The same, this case, 5 of those 6 metrics, some good level of significance, but still some flying monkeys because of this. So we only had, again, they're mostly single metric sites. We had 2 sites that had 2 metrics, and that was as good as we got. And then at one of them had 3 metrics, but they were in reverse directions. So again, some interesting things here in the short-term trends, but not very compelling. So the flow data analysis. Now this is where it gets a little more intense. Statistics, so prepare yourselves. This again is, are there trends in flow that can't be attributed to precipitation changes? So data handling was a little more complex here. We selected sites with both stream flow and precipitation data. That's kind of a given. There were 10 sites that met that criteria. We used our, what we call our storm chunker model to go into the flow records and desegregate the annual record into discrete storms. So we only had 5 to 6 years of flow data for these sites. So we decided early on that we didn't want to look at annual flow statistics because we wouldn't be seeing anything. So we went through this effort of finishing the updating of the Windows 8.1. And while we were updating, so I'll,
You got 4 hours.
Oh, good. I think I'll be done by then. So anyway, so we used our storm chunker to desegregate all of the storms out of the annual record, so we had a lot more data points to look at, and use that same model then to calculate peak storm flows, storm volumes, and rainfall depths for all of those sites. And then applying the statistics couldn't fit in the square. So, so the first thing we did was do some linear regression on these pairs of metrics. So linear regressions on peak storm flows and rainfall depth and volumes and rainfall depth. Then went through, visually inspected the residuals, looked for where you might be violating linearity conditions. And what that looked like was this. So the furthest left is the rainfall in, say, the top one, peak flow relationship. And as we all know, we know that there's, of course, a good, strong relationship between peak flows and rainfall depth. But the point is that if that relationship was entirely driven by rainfall depth, everything would line up neatly along that red line. And in fact, of course, they don't. And that's what we're trying to ferret out, tease out of the data, is what is happening that's not related, that can't be directly related to these precipitation data. And then you would see in the final graph that when we did look at linearity, it didn't meet that test, so we had to do a log-log transformation of the data. This is the same data now, just again, all log-log transformed. And then the last thing we did in the statistics is we just said to ourselves, we wanted to correct also for seasonality. So you know that if you get a 1-inch storm in December, it is different than a 1-inch storm in August when the watershed isn't saturated. So we just did applied them as binary variables and reran the analysis. And so these are kind of, one of the zillions of plots that we looked at, but it's this final one, then is the final step in the analysis. And I don't know why part of it's not showing up. Oh, how about that? So in this case, for this particular site, when we looked at the relationship of volume to rainfall depth and then made all these corrections, we did see that there was a significant increase in volume between the time periods that could not be attributed to these rainfall statistics. And that's what this table is showing. So this is showing for all of the streams that we were able to look at. There was a result for both storm peak flows and volumes. And you can see at in 3 instances, there were decreases, so significant decreases in flow. And in 4 cases, there were significant increases in flow at these sites. So the important part about all this is really not necessarily these results, but developing this methodology for looking at these rainfall statistics and flow statistics so we can move on to the second phase of the study. And then, I thought, well, for fun, even though this isn't really what we set out to do, what can I say about what we saw with the Benthic trends and what we saw with the flow trend? And maybe this doesn't deserve the Wicked Witch of the West, but I figured I was presenting statistics and I needed something to make this interesting. So there is, one no flow trend noted that we were able to identify for most of the sites where we saw some benthic trend. And then I also asked, I went back to Morrow and said, well, can you tell me anything about what you've done in these particular watersheds, which is really kind of a leap. And in this case, there was a program in 2013 to do large woody debris placement in the One Creek, where we did in fact see an improvement in benthic trends. But not so much we want to rest our hats on those kind of results, but I thought I would present them. So in summary, I think that there are maybe a few macroinvertebrate metrics that we can look at that might serve as more sensitive indicators or early indicators of trends. I think that we really would want to look at entirely different data sets to see if we see those same metrics come up to the top, like the clingers and the predators. It would be very interesting to see if other people saw the same things. The long and the short-term macroinvertebrate assessments we did were not very compelling. There weren't very many sites to look at, not much significance, and very little in the way of multiple metrics showing consistent trends. And then finally, after controlling for rainfall runoff responses, we still were able to demonstrate that there were significant trends in some of these streams. And in terms of the yellow brick road, in our next steps, we're going to actually be taking that flow data and really moving it into looking at more spatial and temporal trends in the data. And one of those might be coming back around and looking at whether they can feed into the metrics and the macroinvertebrate analysis. And with that, unless we want to do the Windows 8.1 update again.
I'll take questions.